Hello, today's topic is complex numbers. Let us begin. What is the meaning of complex numbers? Complex number means, I give you an example. If I say under root 9, all of you know that under root 9 is 3. But if I ask you what is root minus 9, your answer will be, sir, we can't get the square root of a negative number, so it is not possible. Now I want to tell you that it is called complex number. Under root minus 1 equal to I. This is a complex number. So if I say under root minus 9, you will have to write 3i, because under root 9 is 3. As there is a negative number inside the root, we will have to put I with it. I give you another example. Under root 16, you know it is 4. So under root minus 16, you have to write 4, and with it you have to put I. Under root minus 16 equal to 4i. So we have understood that under root minus 1 equal to I. Squaring both the sides, we get minus 1 equal to I square. If we multiply I both the side of this expression, we will get minus I equal to I cube. And if we square both sides of this equation, we will get 1 equal to I to the power 4. So you have to remember that I square equal to minus 1, I cube equal to minus I, and I to the power 4 is 1. Whenever we will solve any expression containing complex number, we have to put these values. Now we come to the next line. As I have already told you, under root minus 9 is 3i. Under root minus 16 is 4i. Under root minus 17 is under root minus 17. You will have to write under root 17, and with it you have to put I. So under root minus 17 is root 17i. If we come to the next example, this is root of root 3 minus 2. Root 3 minus 2. Root 3 means 1.732. Root 3 minus 2. This is a negative number. So what will we get? Root of root 3 minus 2, we will have to make it positive. We will write it 2 minus root 3. Now it is positive. We will have to put a sign root, and we will have to write I. So let me explain it again. Root 3 minus 2 is a negative number. If we want to find its root, we will have to make it positive. You have to write 2 minus root 3, and with this 2 minus root 3, this is a positive number, we will have to put root sign, and we will have to write I with it. So this is what we have learned. Next topic is real and imaginary part of a complex number. For example, if I write 2 plus 3i, here this part, this value 2, it is a real part, and this part 3, it is imaginary part. Let me explain it again. If I write z equal to 2 plus 3i, and if I ask you what is real part of z, you will write 2. And if I ask you what is imaginary part of z, you will write 3. don't write 3i. 3i not imaginary number. The imaginary part is 3. The real part is 2. If I ask you, what is the real part of this complex number? You can see that there is no real part. So you will write real part of z is 0 because there is no real part, and imaginary part is 3. Imaginary part is 3. I give you another example. If I ask you, if z equal to 5, what is the imaginary part? You know that this is the real part, but there is no I. It means imaginary part is 0. It means imaginary part is 0. I think it should be clear to all of you. Now we come to the next point. The next point is conjugate. If I write 3 plus 4i, our complex number is 3 plus 4i, this one. Its conjugate is 3 minus 4i. It is very simple. Just change the sign of imaginary part. Means just change the sign of the coefficient of I. If I write 2 plus 5i, its conjugate is simple, 2 minus 5i. Just change the sign of the imaginary part. It is called conjugate. Now next topic is simplification. Now we should do some simplification problems. See these examples. This is the first example. The question is minus 5i into 1 upon 8i. You will do a very simple mathematical operation. Minus 5 into 1 by 8. You will get minus 5 by 8. Now I into I, you will get I square. And we have learned earlier that I square is minus 1. This is minus 1. Minus 5 into minus 1, you will get 5. So the answer is 5 by 8. It is so simple. The answer is 5 by 8. Now we move to the next part. You can see it. It is minus I into 2I into 1 minus 1 upon 8I whole cube. First, if we multiply these two terms, minus I into 2I, we will get minus 2I square. And if you simplify this term, minus 1 upon 8I whole cube, you will get minus 1 upon 512 I cube. Minus 1 upon 512 I cube. Now again we will simplify it. You know that I square is minus 1. This is minus 1. So minus 2 into minus 1, you will get 2. And I cube is minus I. Minus I into minus 1. Minus I into minus 1 is I. I upon 512. We will get I upon 256. Because we can cancel 2 and 5 and 2. We will get 256. So our answer is I upon 256. Now I show you the solution written in the book. You can see it here. Just a minute. You can see the solution, but I have told you the solution. and here it is. You can see the first part we have got 5 upon 8, and in the second part we have got 1 upon 256i. This is the solution of the book. Let's move to the next part. Next part is the polar form. First of all, let me explain you what is the meaning of polar form. We have this complex number z equal to 1 plus I root 3. The real part is 1 and the imaginary part is root 3. 1 root 3. 1 comma root 3. If you plot this point, 1 root 3 on the graph, you will get this graph. This point is 1 comma root 3. And polar form means you have to join this point to the origin. Origin is O. So this line OP represents this complex number 1 plus I root 3. And if we find the length of OP, if we have to find the length of OP, it is called modulus. This is called modulus of complex number, modulus of z. And the formula is very simple. Modulus is under root a square plus b square. What is a? This real part is a. 1 is a. And what is b? B is root 3. You have to put these values here. You will get root a square means 1, b square means 3. You will get 2. So the length of OP is 2. It means the modulus is 2. This is the modulus of this complex number. Now I come to argument. What is the meaning of argument? Argument means the angle made by this line with the positive x-axis. You can see this angle theta. The angle between the line segment OP and x-axis is known as argument. We have to find this angle theta. The formula is tan theta equal to b upon a. Tan theta equal to b upon a. What is b? It is root 3, imaginary part. And what is a? It is real part, 1. So we have got tan theta equal to root 3. And you know that root 3 equal to tan 60. Root 3 equal to tan 60. So what we have got? Tan theta equal to tan 60. It means theta equal to 60. Theta equal to 60. And in polar form, we write this angle in radians. Theta equal to 60 degree, and 60 degree is equal to pi by 3 radians. This is our argument. So to get a polar form, we have to find the modulus, and modulus is 2. And we have to find the argument also. Argument is pi by 3. So both the things we have got now. So what is the way to write the polar form? The method is just write r cos theta plus I sin theta. Let me show you the answer. Now you can see it. Here you can see. Z equal to 2. 2 means modulus. We have got Z equal to Z mod equal to 2. Earlier we have got it. And theta we have got pi by 3. So the way to write polar form is Z equal to R, and in bracket we have to write cos theta plus I sin theta. This is the answer. This is the polar form. That's all for today, and in the next video I will explain some other topics. Thank you very much.